with simplifying radicals. So the first vocab term here is monomial. So a monomial really is just a singular term that can be a combination of coefficients and multiple variables. But the monomial that we are looking at in this lesson are square roots with variables. All right. So please write this first section down. So the square root of a to the m power. So if m is a multiple of 2, because remember, the index on our square root is 2, then use the rule that the square root of a to the m would be the same as saying a to the m divided by 2. So you're going to take your index and divide it by your exponent. So if n is not a multiple of 2, break it apart. So if I have the square root of a to the m, that equals a to the m minus 1 over a to the first power. So this in total would equal a to the m minus 1 divided by 2 power times the square root of a. So this right here, I find all of this to be quite confusing, especially when you're first learning. So I think diving into the examples is really going to help to clear a couple things up here. So if I have the square root of x, okay, we can work our way down quite a few of these examples. So if I have the square root of x, that's the same as saying the square root of x to the first power. Well, I know my square root has an index of 2, so since 1 is not divisible by 2, I'm just going to leave this as the square root of x. Okay? For my second example here, I'm taking the square root of x squared. So I'm going to take my index, which is 2, and divide it by my exponent. So this is the same as saying x to the 2 divided by 2 power, or x to the first power, which is just x. Okay? So I could divide this by my index only because it is divisible by 2. In a case like this one, x to the third power, 3 is not divisible by 2. So what I want to do is I'm going to split up my x to the third power so I have a part that's divisible by 2. So I'm going to split up my x to the third power to be the square root of x squared times x. I'm going to rewrite that quick. Okay? We know that if we multiplied x squared and x, that we would get x to the third power. So I'm just splitting this up. Okay? Out of my parts that I split up, only my x squared is divisible by 2, which would be my index, not x. So x, I'm going to leave it as a radical, but I am going to divide my x squared. So x squared, so the square root of x squared is going to turn into x to the 2 divided by 2, and I'm going to leave my square root of x. So this is going to simplify to be x times the square root of x. Okay? So my next example here is the square root of x to the fourth power. 4 is divisible by 2, so I'm just going to divide it right away. X to the 4 divided by 2 power. 4 divided by 2 is just 2. So I've got x squared. All right. So we'll go through the rest of these in class together. I think it would be good to go over a couple together just to make sure you guys are able to ask questions, especially when we have exponents that aren't divisible by our index. So let's look at a couple more monomial examples. These ones have a variety of different variables, and coefficients and everything else. All right, so taking a look at these, we do have more examples on the back side too that we can dive into. So taking a look at these, I'm just going to do the top two. So I've got the square root of 64 times p to the fourth power. So really, I'm going to try to simplify both of these separately. I'm going to start with the square root of 64. So I've got the square root of 64, and I've got the square root of p to the fourth power. So I know from the previous lesson that the square root of 64 is just 8. And I have p to the fourth. Actually, I'm going to write my 8 a little further over here. And I've got the square root of p to the fourth power. Square root has an index of 2. 4 is divisible by 2. So I'm just going to make this p to the 4 divided by 2 power. 4 divided by 2 is just 2. So this gives me p to the second power. So that's how you would simplify a square root with both a coefficient and a variable. All right, over here, I have the square root of m to the sixth power. Remember, square root has an index of 2. Since 6 is divisible by 2, I can go ahead and divide these. So I've got m to the 6 divided by 2 power, or m to the third power. Okay? That is how we'd go about simplifying those two. Okay? Write down these other two. We will go over those in class together. All right, on to the back side. So these ones are quite a bit more complicated. So I'm just going to go over, maybe I'll go over half of them right now, and then we'll save the other half for class. So with these, just like that example, the square root of 64 p to the fourth on the last page, let's start by splitting these up. So I've got the square root of 100, square root of x squared, and the square root of y squared. So I'm going to simplify each of these separately. So the square root of 100 is just 10. The square root of x squared, well, 2 is divisible by 2. X to the 2 divided by 2 is just going to give me x to the first, or x. And same with y. Y to the 2 divided by 2 power, which is just going to give me y. All right, continuing down. So with this one, let's go ahead and split it up again. So I've got the square root of a squared times the square root of b cubed. So starting with a squared here, a is, 2 is divisible by 2. So this just gives me a to the 2 divided by 2 power, which just gives me a. But in a case like this, with b cubed, 3 is not divisible by 2. So I'm going to have to split this one up. So I still have the square root, but this time I'm going to split this up to b squared, so that can divide out just like our a. Well, b squared times b gives me b cubed, so that's how I'm going to split this up. Okay? So the square root of b squared, same as saying b to the 2 divided by 2 power. And there's nothing I can do with the square root of b, so I'm just going to leave it. So this ultimately equals b times the square root of b. So my final answer for this one would be a times b times the square root of b. All right, continuing down, very similar problem here. So let's start by splitting up both of my parts here. So I've got the square root of 144 times the square root of k cubed. Obviously, k cubed is going to simplify very similarly to b cubed. So the square root of 144, if you remember back to your perfect squares, is just 12. And k cubed is going to simplify. Split this into k squared times k, which we can simplify as k to the 2 divided by 2 times the square root of k. So that just equals k times the square root of k. There we go. All right. This last one is a little bit of work, but we'll get through it. It's a good example. So in this one, I still have only one term, yet I have a coefficient, an x value, a y value, and a z value. So we're going to have to split all of those up. So this one's going to take a little bit of work. So I've got the square root of 63 times the square root of x to the 5th power. Try that again. Times the square root of y to the 25th power times the square root of z to the 14th power. So I just split up all four parts. Now we're going to attack one at a time. So if we're thinking about our perfect squares here, 63 is not a perfect square. But thinking about my perfect squares, I'm just going to list a few over here. Got 1, 4, 9, 16, 25, 36, so on and so forth. If I'm thinking about my first couple perfect squares here, I do know that 9 is divisible by 63, so let's start there. So I'm going to split 63 into being 9 times 7. And now I'm going to break up my radical. So I've got the square root of 9 times the square root of 7. The square root of 9 is just 3. And I can't simplify the square root of 7, so I'm just going to leave it. All right, now let's go ahead and break down our x value. So obviously 5 is not divisible by 2, so let's break it up into a part that is. So I know that 4 is divisible by 2, so I'm going to break up my x to be x to the 4th times x. Once again, I can split that as well. 4 is divisible by 2, so I've got x to the 4 divided by 2 power times the square root of x. 4 divided by 2 is 2, so I've got x squared times the square root of x. Okay, I'm going to highlight my final products here because I'm noticing this is going to get a little bit messy. All right, y to the 25th power. I'm going to split that up as well. So I'm going to split that up into y. 25 is not divisible by 2, but 24 is, so we're going to go with that. Times y. So I've got y to the 24th times the square root of y. 24 is divisible by 2, so I'm going to make that an exponent. Times the square root of y. 24 divided by 2 gives me 12. So I've got, I made this x all of a sudden. I meant to make that y. So I've got y to the 12th power times the square root of y. And then finally, I've got my z value, which I realize that my work is getting a little over there, so let's give ourselves some room. So this one's actually the nicest one. I have z to the 14th power. 14 is divisible by 2, so let's just make this z to the 14 divided by 2 power. 14 divided by 2 is 7, so I've just got z to the 7th power. Nice. All right, so now that I've simplified each of my components separately, now what I'm going to do is take all of my radicals and combine them together, and all of my coefficients, or numbers outside of my radical, and put them together. So my numbers outside, I've got 3, x squared, y to the 12th, z to the 7th. Okay, then underneath my radical, I've got 7, x, and y. So that is my final answer for that one. All right, so I know this was a ton to digest in just one lesson here. We will make sure to do a ton of these examples in class so that we have everything straight. All right, well, thanks for watching. Make sure you bring any questions you guys have to class.